For decades, scientists believed planets got their water from comets and asteroids crashing into them from space. But what if we've been wrong this whole time? What if planets can brew their own water, deep within their cores? A groundbreaking discovery just turned our understanding of planetary water upside down. I will show you how this changes everything we know about worlds beyond our solar system, and maybe even our planet Earth. Astronomers have discovered hundreds of exoplanets of different sizes between Earth and Neptune. Many orbit incredibly close to their stars, much closer than Earth orbits our Sun. When scientists calculated their densities, they found something puzzling. These planets appear to have rocky cores covered by massive layers of water or hydrogen. But here's the problem. There's a clear pattern in our solar system. Inside the snowline, water evaporates because it's too hot. That's why Venus and Mercury are bone dry. Outside the snowline, planets like Saturn and Neptune are loaded with water and gas because it's cold enough for these materials to condense and stick together during planet formation. So how did these water-rich exoplanets end up so close to their stars? The leading theory was planetary migration. They formed far away where water is abundant, then slowly drifted inward. But a team of researchers just discovered something that challenges this entire narrative. These planets might not need to migrate at all. They might be making their own water right where they stand. To prove this theory, researchers led by planetary scientist Harrison Horn had to recreate the extreme conditions deep inside planets. They took olivine, a mineral abundant in planetary interiors, and placed it inside a diamond anvil cell device. Then they introduced hydrogen gas and blasted the sample with high-powered pulsed lasers to generate the crushing pressures and scorching temperatures at the boundary between a planet's rocky core and its hydrogen atmosphere. The experiment was challenging. Heated hydrogen kept infiltrating the diamond's structure, causing it to shatter repeatedly. Horn admits he broke a lot of diamonds, but the results were absolutely stunning when the experiment finally worked, using pulsed lasers instead of continuous beams. Quote, "There was no rock left. All I had was metal and water," Horn recalls. The hydrogen had stripped the oxygen atoms from the minerals, and those oxygen atoms bonded with hydrogen to create massive amounts of water. We're not talking about a few drops. About 18% of the initial rock's mass was converted into water. That's thousands of times more water than we'd expect for a planet like Earth. The team was shocked. This wasn't just a chemical curiosity. It was a potential explanation for an entire class of water-rich worlds. Based on these findings, researchers estimate that planets using this water brewing process could have water content ranging from 5 to 28% of their total mass. This would create massive ocean worlds, 2 to 5 times the size of Earth, completely covered by deep liquid oceans, potentially hundreds of miles deep. Or they might form what scientists call Hycean worlds, planets with an ocean covered by a thick layer of hydrogen gas. The researchers emphasize that these aren't two completely different types of planets. They're related, like cousins in a planetary family. Whether a planet becomes a pure ocean world or a Hycean world depends on factors like how close it orbits to its star, size, and starting composition. The key insight is that the water comes from within, not from space. This discovery has huge implications for the search for alien life. Recent studies suggested that Hycean worlds might trap most water deep in their mantles, leaving their surfaces dry and lifeless. However, as astrophysicist Remo Byrne notes, this new research moves the water abundance back up. They could harbor life if these planets have abundant surface water. Evidence from tiny water pockets trapped in ancient deep Earth diamonds supports this. They have a different chemical signature than surface water, suggesting Earth may have two water reservoirs: primitive water from early chemical reactions and water delivered later by comets and asteroids. We're not just passengers on a wet rock that got lucky. We might be living on a planet that helped make its own oceans. And countless worlds might be doing the same thing across the galaxy right now.